week 7, we spent some time reviewing the prior outside research project. John, since you're here, do you have any thoughts that you particularly remember from that conversation that you'd want to share?
We talked a lot about how there is a theoretical datum and a tangible datum.
We cycled back to Datum, and we also talked about how several of the articles were basically covering the same ground. And I think I would say that a lot of us had trouble wrapping our brains around the larger abstract definition of datum. And I always thought of datum more as, for example, an elevation marker. It's a discrete point. In the case of an elevation marker, it represents an invisible plane that might represent the floor of a building. So that's a very obvious datum. Could you elucidate a little bit, Joan, on the more nebulous one? Because that was a
Yeah,
really interesting conversation.
yeah, and I think Charlie really said it best because he was like the datum is also what the artist wants you to see. It's what the artist wants you to pick up from their drawing. So for instance, he did one of the that one elevation that didn't have um any dimensions on it. So he did a rough sketch of that, and we were talking about basically the artist wants you to see what this house looks like on the site in its final place with all of the trees and everything around it. And we kind of just elaborated from there, where each elevation would have its own um the artist intentioned datum.
It was a fascinating observation. To him, that overarching datum was the relationship of the wood house to the forest around it. And I was actually very startled by that because that's exactly what the owner and I wanted to achieve. And I wasn't necessarily expecting that to come through in one elevation. So the idea that a datum could be abstract, right? Like you were saying, Joan, a
Mm-hmm.
vision. Um, that's probably the farthest out there that we got. And so we just kicked that around for a while and tried to really kind of grab onto that again and just spend a little time talking about it.
Yeah, so
Okay.
and then in my assignment, when you were asking for the what is the datum of the interior elevation, the exterior elevation, I came up with the three main for the bullet center, that south elevation. I think I came up with, there's the datum of the actual facade of the building, including all of the metalwork in the windows. There's the datum of the roof line, including all that oversized all that oversized solar panel configuration, and then also kind of the datum of the sloping of the land as well. So those were the three kind of main ones that, I mean, and but like we said, a datum could be so many things.
So I think the biggest takeaway that I would have, because I found that a really fascinating research project myself, is that you can think of datum in two different lights. One is a discrete data point, if you will, or plane or line that, might be more technical. Again, back to that elevation marker. But then the other way of looking at it is a bigger picture, maybe for space planning and organization. So it's good to be aware that there can be two broad concepts that it falls within. Yeah. Um, does that kind of make sense, Ethan?
Yeah, I think it does. So there's like a more technical version of datum, and then there's also a more abstract version of datum that's a little more bigger picture of like the building in relation to the environment or the cabinets in relation to the countertops.
Seems to be. Yeah. And it was interesting for me to look at this because in terms of space planning and massing and all that stuff, you study all that, but using datum that way was very interesting. So, yeah, I would just roll with those two: abstract, concrete.
Okay, that makes sense.
Yeah. I think then, what else did we do? So, there's an article in D2L, Key Players in the Construction Process, and we buzzed through that. And it's actually perfect that you're here, Joan, because when you look at that article, and probably the best thing is for you and Riley to read it. It's in week 7, and it's the one with this picture. And so I would say the important takeaway from this particular article is it's written towards the audience of a client. So somebody who may or may not know anything to speak of about construction or architectural drawings. And so, this is broken out into overview of different professionals, but then it has sections on how do you find and hire the right professionals, what are the benefits of a project manager, and who can help me design my plan set, and then what is this again about permitting. So that makes it a good general article for our purposes, but it's important just to acknowledge it's written for a client who's not necessarily a builder. And
Okay.
so in that first part, it's not a very long article. In that first part, it has 5 bullet points of different stages within the construction building process. And so as we were talking about that on Friday, Joan, you brought up a punch list. And
Oh yeah,
I
yeah.
was
I
super
wanted
glad.
to make sure that Ethan knew about that because they've
Mhm.
got this the 5 stages of construction,
There
and
should be 6.
yeah, there's it basically it's like, okay, you've got construction and everything's being done, and then when the construction is over, you just hand the keys over to the owner, and it's like there is so much little detail work that happens in between the construction phase and when, like, that final invoice gets paid, where and it's called a punch list. And I just know this because my dad is a carpenter. That's what I used to go around to job sites with him, and he'd be like, all right, look for any blue tape that's still on the floor, or a ding in the wall, or sometimes hard you'd go into a room and there'd be like no hardware on the cabinets and stuff like that. So all these little things you know just kind of fall through the cracks during the major construction phase. So it was an entire job.
Wow.
Yeah, it's like that detail moment, where you think it's done, but now we're going to go over it with a fine tooth comb. Have you heard that term before, punch list?
No, I have not. Before we move into this though, what was the link for the article in week 7?
The who's who of the construction building process.
Oh, it might be in week 6.
Oh, thank you. Yeah, it might be in week 6 because technically I think this was part of week 6. I printed it back on the 19th of February. So it was, yeah. Here, let me pull it up. Are you finding it in week
Okay.
6?
What was the title of it?
The who's who of the
The
construction
Who's Who.
building process.
Okay. I'm not seeing that yet.
Let me go look. So this doesn't use that term punch list, and it should. I think it does not, maybe because it was written for, John Q. Public. Best guess.
Oh,
But
maybe it was even week
it's a
5.
very standard thing that I've never heard of anyone not doing.
Oh yeah, it's in week 5.
I'm going back. Oh, did you find it?
It's the last link in week 5.
Oh, it's
Yeah, it's basically a
yeah, I see it.
it's yeah, you could skim it and really take away everything that you need to. But punch list wasn't on there, and that's a super important thing that anybody who's doing buildings needs to
Mhm.
know about.
I think so. Yeah, it was funny because I was reading that list. We had the article up on the overhead, and I was thinking to myself, now where's the punch list? And then Joan's like, where's the punch list?
Yeah, it's yeah, it's just it's a because and my dad worked for a company that did a lot of restaurants. So before they could open, you need to have, some of it would come down to having that sign that says employees must wash hands
Mm-hmm.
up in the bathroom, like little stuff like that. But so much of it,
So like all the little tiny finishing is on everything.
little tiny details, or you open up a door and maybe it's a little stiff and you have to throw a little oil on the hinges. It's just getting the building
And the finished
into an
floor will
operational
raise
state.
also, like if you're doing different surface, like tile, carpet, what have you. And then sometimes you have to plane the bottom a little bit so it doesn't stick. So there's all kinds of little odds and ends, but there's, more, I would say, forgetting to take the painter's tape off, forgetting little widgets.
Mm-hmm.
It's just it's pretty involved, and contractors have to be super careful when they're working that they don't, like, let's say that you'll see the contractors will put cardboard down all over a wood floor so that they don't run the risk of scraping it, because if they do, a good one will then refinish the floor. So there's just a lot of little very careful things that are done during the construct, like wearing booties, like surgical booties, or wearing shoes that don't mark the floor. And if you get like one piece of gravel and it causes a little ding somewhere, you want to fix that. So that yeah. So punch list is that list of little dings or forgotten things that you
Like
could still
touching
live in
up.
this space. It's functional, but it's not yet perfected. So the punch list needs to be addressed also. And then people say, okay, we're done. Here's your last check. So,
Okay.
what else? We talked a little bit also during the review of Independent Research Project 5 about exterior building elements. And I would say nobody had really studied those very much. And so everybody was kind of drawing a blank. So my best
Mm.
advice there is go back, study your notes from last week on exterior building elements, because you don't you guys don't have to memorize all this stuff. You should be familiar with it. Like you're going to
My
hear these terms over and over again.
my mom does building exteriors. She does sheet metal. She does the drawings for like flashing and stuff on buildings.
Oh, cool.
Yeah.
So have conversations with her over tea or coffee. Ask her to if she'd be willing to show you her drawings and walk through them
Oh
with you.
yeah, we've she's shown me a couple. We've walked through them. It's really interesting. It seems like a lot of the exteriors is mostly about just keeping water away from the building and making sure that like there's no long-term damage caused by weather and erosion.
It's true. Yeah, it's a good observation. Um, but it's kind of like people have anatomy, like you have your thumb and your finger and your hand, your wrist. Buildings
Yeah.
have anatomy also. And it's better to be able to say, the flashing rather than, that stuff up there in the corner. And
Yeah, the proper terminology.
so try and grab onto some of that. Um, and then I think so we talked about all this a little bit, and then we kind of went into um, the topic of the day. We delved into plumbing, and because to me, plumbing would be incomplete, like it deals with water on the inside of a building,
Yeah.
but also how you get water into buildings, and then how do you get the water and the waste safely out again. But to me, that's incomplete without at least acknowledging there's a larger cycle in play. And so we divided into groups again, and it's all in D2L, but there are two diagrams of plumbing risers, and one
Oh,
of them I drew back in Chicago some years back, and then the other one I just grabbed from the web. And I guess the big thing about plumbing risers is there's a heck of a lot there to learn. And not every architect draws them. In fact, that's often something that a master plumber will work on or that an engineer will design. And so, do you remember in the Chicago building that people were working with for plans a couple weeks back? Some people, anyways. There was a plumbing wall, and that came up during studio. People were asking, "What is this?" Do you
yeah, I
recall?
remember the plumbing wall.
So the plumbing wall is a hollow wall. And when you're working on buildings, you have to know that you have to have pipes going up and down through the structure. You have to be logical about organizing where things are. For example, bathrooms are normally stacked floor by floor on top of each other because you can run one set of piping up and down through a cavity wall, a plumbing wall, and it's all right there. And the more you snake pipes around in walls and floors and ceilings, the more joints you have, the more expensive it is, the more risk of a leak springing. So, some common sense things you can know and then design the building successfully, even without knowing every last detail about how to design the plumbing risers. And then often you'll see, so the plumbing risers is what's bringing water in and up and down to toilets and sinks and showers. Um, I have baseboard hot water heating in my place. So there's a separate plumbing system for that that runs right off the boiler. So all of those things, right? But then what do you do when the water goes out of the house? And a lot of times there will be two riser diagrams, like you see this in the one that I drew that's up in D2L. You have plumbing riser bringing in the good water and a waste diagram bringing out the used water. So that's conventional construction, and that would be on city water. And then we talked about there's some interesting articles in there. You can also look in the discussion thread for this last Friday, and maybe start with those and then go back and look at the articles that you
Okay.
want more information from. And then there's a video to watch. Um, I was hoping to show it in studio. We ran out of time. The video is by a civil engineer and it's part of an online course. And so what we have is the free part, which is 30 minutes long. And you need to look at your classmates' notes first, look at some of these articles first, and then take as much as you can from the video. Don't go straight to the video first. It's a bit overwhelming.
Okay, that makes sense.
So then we also looked at the larger context. Where does the water come from and go to after we use it? And so all of this relates directly to the next independent research exercise, which is number 5, I believe. And so we talked about some green building strategies. So there's earthships, and those started in Taos, New Mexico, with a guy named Mike Reynolds. And they've actually stood the test of time fairly well. We talked about living systems. And at the time that I was a graduate student, I was actually researching those. They were kind of a new thing. And they're really cool. They've also stood since the 90s the test of time. And so there are some different articles on those. So the conventional water cycle for houses and plumbing is city water. And so you have water under pressure from the city waterworks, goes through pipes to each house, and then it goes through the house, and then the dirty water that comes out of sinks and showers and toilets drains back down through the house on a gravity feed system and out into sewer pipes and then to water treatment facilities. And water treatment incorporates different techniques, right? There might be settling tanks where solid settles and then the water flows on, and then it might be filtered. And the filtration is meant to take out a lot of things. And, not just leaves and twigs, but other, certain chemicals and so forth as well. And then it goes through chemical treatment, which is usually chlorine, like most city water is chlorinated. And so you get all of these treatment stages, and then it goes, back to the houses again. And so we talked about that. There's different articles. Again, I would start with looking at your classmates' notes. And we have Joan to thank. I think you said you put everything up. Did you catch everybody's notes?
No, I put my notes up about the living machine
Perfect.
and your diagram that you
Oh, thank
drew
you.
about the conventional water on a
Mhm,
city system,
mhm.
conventional on a septic, and then your diagram of the living machine. And yeah, so basically, Ethan, my part of the presentation was there are two kinds of living machines. There's living machine, the company, which actually makes and facilitates these tanks where it's like
Mhm.
one tank to another tank to another tank, and they're
Mhm.
using plants to help filter this water.
That's
And
really
you
cool.
have the example of that place in Denver, right?
Ethan, have you heard of the Grow House? I'm gonna put
Sorry, no, I have not.
I'm gonna put that in the chat if I can find. There's the chat. There's the chat. Okay. It's called Grow House. That's it. And you can find these guys in Denver, and what they do is they're down in, like, they're in the neighborhood with a lot of lower income people and the worst air in the whole city because of the factories around it, like the Purina factory, for example. And so it's a warehouse with operable skylights. And what this enterprising group of people decided to do was create a version of a living machine. And so they're doing hydroponic farming, and they have tanks, water tanks with fish. And so the fish poop in the water with the fish poop fertilizes the plants. The plants' roots clean the water, and then the fish are happy again. So it's this cycle, and it's fairly steady state. They don't lose, they lose some water to evaporation from the hydroponic stuff, but it's actually very, very efficient, and they're growing organic produce. It's fabulous. And so that's one kind of living machine. And then actually, the original Earth ships all had south glazing. They're all in the high desert environment, very cold nights, very sunny days, and high altitude as well. So lots of solar radiation. And they all had gardens along the south glazing, but the planters were all at a bit of an angle. Not so much that everything slid downhill, but it's a bit of an angle. So water would run downhill. And what this allowed was that the gray water from sinks and showers was funneled into these planters. The plants loved it, and then filtered the water as it went past, grew big and tall, provided an indoor food source. And then the water that came out the end was, um, I don't know that I'd go so far to say that they proved it was potable, but they did definitely demonstrate that it was clean and it could be reused in other ways as gray water. So the original, like back in the 90s, the original Earth ships didn't have tanks. They had these long planters that ran along the windows. So these are some different water recycling methods that are, a little more, I don't know, I guess we could call them unusual. Um, and on the Earth ship, not the Earth ship gardens, on the living machine, the largest one that I know of is at a place called Findhorn, which is in Scotland. It's on the North Sea. Have either of you heard of Findhorn?
No, did we talk
Oh,
about it in class a little bit?
I think it was mentioned, and I have some photographs. I was there and loved it, but um, I was like, you guys have enough this week, you know. But Findhorn has an eco village, and they needed to treat their wastewater special. They couldn't do the normal city water thing because they're right on the shore of the North Sea, and they didn't really have the land or the resources like we might have in the Midwest or even in Denver. And so they had to be very careful not to pollute the ocean. So they set up an eco village with the water driven by a living system, and it's been working since the 1990s, like 30 plus years, going strong. They also do biodynamic gardening, and like their raspberries are as big as your thumb. They're really good. So, it can, that's the biggest one I know of, and they actually work. So we just talked about the two conventional systems and then two green or alternative systems. We also touched on the fact that the Bullet Center third floor plan, which I believe is in D2L, is
yeah,
a constructed wetland, which is another variation, really, of a living machine, if you will.
yeah.
They,
I remember us looking into that one
yeah.
pretty early on at the constructed wetlands, and you
Mm-hmm,
could kind of see a little bit of it in the plans.
mm-hmm. So, so then, that pretty much was that. But by the time, people had divvied up into groups and grabbed articles and shared them, we were pretty much out of time for the video. So everyone has to watch the video on their own.
Okay, so I'm gonna go through the classmates' notes and then the articles and then watch the video.
Yes.
So
And
it looks like the only I uploaded your diagrams about the conventional and the living machines, and I uploaded my notes about living machines. I have a few notes about earthships that I'll add, and then the other the plumbing riser diagrams, um
the
we don't
riser
have the
diagrams are in D2L.
right, but we don't have any classmate notes. So I'll upload the notes that I took about the earth ships, Ethan, so you can kind of take a look at them, because Kendra did a
Yeah, that
pros
sounds
and
great.
yeah, Kendra did a pros and cons list
Yeah, that
that
article is not very long either. So honestly, you could read the article on pros and cons of the Earthship in like 10
oh
minutes.
yeah.
Okay.
So, and then the notes that I did in my sketchbook, that thank you so much, Joan, for photographing and uploading those. Those are really, you're going to need these. These do not duplicate any of the articles. And there was one other building system I talked about, so it's really only 2 pages of notes. There was one other building system called Flex Shell Architecture. And that's actually really cool. That's this one. And back, I want to say in week 1, we have a detail from this. It was invented by a guy named Doug Lacey, and he's down in southern New Mexico. And the columns are, he uses a thin shell, what's called a thin shell concrete, and it's self-healing. It's very, very interesting stuff. And the columns flare up, and this funnel part is hollow. And then the roof form, if you look at this is actually, his roofs look like this. They're very, very organic. They're built on wire armatures. Um, if you're interested, I can add a link. I wrote an article about Doug's work. So there's photographs in that article. So if you guys are interested, if you think it would be helpful, I can drop links in D2L, and then
Yeah.
you can find it there. I was afraid we were getting too many things in D2L last week. But it's very, very interesting because those hollow columns can be used to catch water. So it runs through those curvilinear roof forms down into these columns,
Um,
and he puts little spigots at the base of the column and harvests the water. The other thing you can do with it is build islands and do gardens. And the gardens basically float on these man-made islands on top of these hollow columns. And between evaporation and the roots going down into the water, it's the perfect, you never have to water your garden. It's like the perfect way to grow a rooftop garden. And then there's a third thing that he did. He has also taken like broken concrete and rubble from landfills and put that in those columns. So it actually is pulling stuff out of landfills. I don't think I mentioned this in studio, but the nature of the concrete that he uses, because it's thin shell, he uses a fraction of the amount that conventional concrete construction uses, and it binds carbon from the atmosphere for the life of the concrete because of the special mineral composition. So it's a really fascinating building material. So we looked at those two, and again, the idea was just let's at least consider the fact that water doesn't just magically appear in our buildings and then leave again. You know, there's a cycle.
Hmm. That makes sense.
Yeah. So if you look at your required learning outcomes, plumbing risers is actually on them, which I thought was really cool. This larger water cycle, kind of not so much, but I think it's just really important stuff. And it ties back into our site work from the other week. So when you go look at page 3, um, Independent Research Project, I think it's number 6, is 2 parts. Part A, take one of the sample plumbing risers that are up in D2L and just see if you can print a copy, or you could redraw it in your sketchbook and then just mark it all up. Your task is to like make little arrows, write little notes, but figure out what everything in that sketch stands for.
Okay, so we'll print out a copy of it and then like put a bunch of notes on it about what each symbol is explaining.
Exactly. Or just draw your own, but yes.
Okay.
And but yeah, printing is great. And then and then there's a longer article that Will presented that has entire cheat sheets of all the symbols, and it's from Illinois.
Oh,
So
nice.
that one, if you need the cheat sheets, you might need to go skim through that article. And then part B is on water treatment, just a very fast overview of various methods. And so there's 5 parts to that. I think I wrote 4 twice, but there's really 5. So you can read about that. Um, but it's just briefly describe where city water comes from and goes to. And you
Okay.
can use my diagram for that. You don't have to go write paragraphs on this. The diagrams that
Okay.
are up in the discussion thread will do just fine. And you can write a little bit with it too, just make sure you understand it. And then living machine, which would be alternative. Well and septic, which is also very conventional. Earthship gardens, alternative. City water, very conventional. So that's it. Hopefully it's not too much for anybody this week. And if you watch the video, you guys, if you can take notes as you watch the video, it will, I think, also answer some of the questions of what are the parts of a plumbing riser? How would you label that, you know?
Yeah, the video is great. The video basically teaches you a lot. And I think it's just really cool. Like, so it's kind of this overall um invisible infrastructure. Like if you could look inside your own body and you know that there's bones and there's a circulatory system and your muscles are all connected and all of that kind of stuff. All of this stuff is kind of like that, but behind the walls of your house, where all of the electricity lives, where all of the framing is, where all of this plumbing, all of these plumbing diagrams all live in the walls. And it's like if you could just like saw your wall in half, you could just see how all of that stuff works. It kind of reminds me of the bodies exhibit. Did you guys ever see the bodies exhibit?
Yes, and it does, doesn't it?
Yeah, that's
That's
what it
really,
reminds me of. It's
that's
like
really cool.
the it's like the it's like the building and construction version of the bodies exhibit.
And I do think it's important to just say again that not every designer designs plumbing systems. It's very specialized. There's a lot of codes, and you'll really get that from the video. We've got articles and the video from different spots around the country. All of them are governed by codes, and you guys are familiar with what that means. And so it's really very precise work. You know, things have to fit together in the right way to keep the system moving and safe and healthy. But if you know the system is going to be going inside the walls, then you know there's going to be piping, you know there's going to be this and that. Then, you know, again, thinking of it like the circulatory system in a human body, you start to say, okay, we're going to stack the bathrooms above each other. We're going to have a plumbing wall. Let's say it's an apartment complex. We're going to have mirror image units so that there's a plumbing wall here and there's a bathroom on this side and a bathroom on this side. One plumbing wall, bathrooms on each side. Plumbing wall runs all the way up the building. Bathrooms stack above each other. It just makes sense. And then you know everything fits.
Yeah,
Um,
like every building I've ever lived in, if it's an apartment building, all of the apartments are the same floor plan
mhm.
that are like stacked all the way up. I think it was like, we had like a six floor building, and every corner unit had the exact same layout with the sink and the bathrooms and everything in the same exact spot.
Now you know why.
Hmm.
So it's important to mention that because a lot of designers and architects, like if you know the requirements for the plumbing wall, you can still design very, very successfully, even if you don't know the diameter of every single pipe, every single joint, every single stack vent. You can leave room for them and hire the person who does. So it's all safe, it works.
Okay. Makes a lot of
So,
sense.
um, you didn't get to hear your colleagues' presentations or, you know, spend time on articles yourself, Ethan, but I think we just did a pretty good synopsis of Friday, and it's a lot to throw at you. Do you have questions?
No, I think you guys did an excellent job of explaining the material covered.
Yeah.
And we'll tackle the chapter from Illinois, which is basically another training manual for, people who are going to be specializing in this. And so when you go into that article, just remember Illinois. It's the one from Illinois.
Okay.
When you go into that article, if you go a few pages in, there are pages and pages of here's what everything is, you know? And so you may see some of those symbols then back in the plumbing riser diagram.
Okay. That makes sense.
Hmm.
So it'll be a
And
good reference.
yeah, so I will stop recording if you don't have any other questions because I think, yeah, Joan, I'm really glad you were here tonight. I think we just went over quite a
Oh,
lot.
yes, of course.
And, you know, Ethan, you and Riley will have to do a little more outside reading, just I think for missing the presentation. So,
Yeah,
but
I think so.
you'll have the cheat sheet even so, and I think you'll be just fine.
Awesome. Thank you very much.